recap what we did so far. If you want to measure the mean, what do we use? If I ask you, I'm sorry, if I ask you to measure the center, what do you use? You use either mean or median, right? If I ask you to measure the spread of the data, I mean how far each data point from the mean, then we're going to use either standard deviation, which is I'm going to explain it to you what it is today, or the quartile quartile range. But we're not gonna study that for this class. So center use mean or median. For the spread, use standard deviation. Okay. So what is standard deviation? Basically, it's how much data scattered around the mean. Like how far each data point from the mean. So first thing I gotta do, say I have a family. This is my population, small population. I got mom, dad, and then 4 kids. I want to know how much is the height scattered around the mean on average, right? So first I gotta calculate the mean. You know how to calculate mean, right? Add up all the height and divide it by the number of the population, which is how many here? 6 here, right? And it turned out the mean is 155. I use centimeter, metric system, centimeter. So now, if I look at individually, daddy, 18 centimeter higher than the mean. The third one is 88 centimeters lower than the mean. That's why you see -8. The youngest one is 15 centimeter lower than the mean. Mommy is 8 centimeter higher than the mean, etc. Right? But what I'm not interested in the individual standard deviation from the mean. I'm interested in overall, like how much standard deviation of all of these people away from the mean, right? So what I have to do is I'm going to take the height of dad. Say I take the height of the first person, which is dad, subtract the mean, and then square it. So the difference between the difference between daddy's height and then the mean is 18, right? I did that, and then I square that number. They give me that one. I do the same thing for this kid, right? Take his height, subtract 155, which is -8, and then square that -8. I got 64. Same thing here. I take this little girl height, subtract the mean, and then square it. I got 225, and so on. So far, so good. Now, why do I have to square? Why don't I just leave it like that? Why do I have to square? Then I add them, but why do I have to square? Yeah, but what happened if I don't square them? Take out your calculator. If you add up all these, what do you get? Take out your calculator. Let's try it out. You have to calculate with you today, right? Three. What you get? If you add all these, not this one, the one that I have not squared yet. How's it equal to 64? I have to make it like that. No. Leave it. You're gonna add the negative as well. Add all these, the difference of the height. Don't change anything. Just raw number. Yeah. What have, and I'll tell you why we have to square. Yeah, it's 0. Well, we don't want 0. It's gonna be boring, right? 0 divided by 6 is 0, right? It's nothing I'm talking about. So the reason we have to square it, because if we don't square it, it's gonna add up to 0. And it's true for any data. Right? If you take the each data point and then subtract the mean, if you don't square it, you total them up, it's gonna add up to 0 always, right? So that's why we have to square it. So the negative go away, negative go away. Right? Once you square it, we're gonna divide it by the sample size, which is 6 people here. And then you get this number. Now, when you square it, it's gonna be centimeter times centimeter, right? Or centimeter square. So your unit's a little bit different. It's kind of difficult to see things like that. By the way, this is called the variance. The variance, but we don't want variance, we want standard deviation. So the next step we do, because we square it in the beginning, after we got our result, we're gonna take the square root. And that's your standard deviation. So the variance is you take the difference between each individual data point, height, age, whatever, right? Subtract the mean. By the way, mu is the population mean. And then you square it. What do you do when you square it? You add them, you sum them up, right? You add all those squares together, and then you divide it by the number of the sample size. That's the variance. So far, so good. Now, it's kind of difficult to interpret it. The height, if I have a number 100, what is that? The 13,233, right? It's kind of difficult to interpret things like that. What I'm gonna do, I'm gonna take a square root. Right there, they subtract, so daddy height subtract the mean square, the third kid's height subtract the mean square, all the way to the last person, and you got that number. But I don't want that. I don't want that number. That is too big. I have no clue when I look at it. What I'm going to do, I'm going to take the square root. So if I take the square root of the variance, now they call that the standard deviation. Right? So here when I take the square root, it's called standard deviation. We put it another way, the variance is the standard deviation square, and the standard deviation is the root of the variance. We'll talk about this in a slide. Now, let me remind you, what is standard deviation? It is how far each data point from the mean. If the standard deviation is big, that means each data point is far away from the mean. Kind of bad, it's statistic, right? If the standard deviation is small, that means each data point is closer to the mean, right? So think of it, if I have here a bunch of people, approximately have the same height, approximately have the same height. When I calculate the standard deviation, it should be what? Small, right? It should be small. Because what you do is you take each of the heights of these people, subtract the mean, you square it. If the difference of, if you add them up, you divide it by the number of people, then the mean should be close to the value of each individual, right? As opposed to I have another population, say I have one person very tall, the other person very little, and then in between, and then really short one, really tall one. When you take each individual height, subtract the mean, you're gonna have a big number, and you square it even bigger, right? So the standard deviation in this group is gonna be bigger than the standard deviation compared to the group where the height are approximately the same, right? So that means each person here, the height is gonna be closer to the mean. In short, if you have smaller standard deviation, that means the data point near the mean. If you have a standard deviation large, your data point is far away from the mean. That's all you have to know. You don't have to know all these. It's my job to explain it to you. Now, there are two slightly different formula. Sigma squared means the variance, population variance. Maybe I'll write that down. Later, you're gonna know those. When I take square root of sigma, what does it become? When I take the square root of the variance, what do I get? Standard deviation. I remember right here, right here. Right here. You take a, oh, this should be a, sorry, this should be a, there's no square there. When I take the square root, the variance becomes the standard deviation. And usually we look at this. It's kind of difficult to look at something square. The number is too big. N is the population size. Mu is your population mean. What is the sample mean? What's the notation for sample mean? I mentioned it before. X bar, right? X bar. That's sample mean. What is xi? Xi is your data point. Your each observation. So that's your data point. Point number 1, data point number 2, data point number 3. We call that xi, all the way to data point n. So if you know your population mean, then you can use this formula. But in practice, we rarely know that, right? I'm not gonna go all over US and collect everybody height, right? It's just not practical. Or if there's a presidential election, you see on TV say they always predict who has the percentage of the candidate gonna be a president, right? That's from the poll. Like I don't remember being asked to guess who's gonna be a president. But what they do is they just take a certain sample out of the population. So on the left-hand side, that's your population variance. On the right-hand side is your sample variance. Instead of sigma squared, we're gonna use S squared. So that's sample variance. Instead of big N, the population size, we have little n, that's your sample size. Xi is still your data point from the sample size, and xi is sample mean. Now, you see that the difference between the population and the sample variance is beside the notation wise. What else different? Beside the notation. Pretty much everything the same, except for the notation and what else? Yeah, but why do I subtract 1? I don't subtract 1 from here. Here, it looks like they take 1 out of the sample size, right? So if you have 10 people, they kind of take all that 1% out and only examine 9 people. You don't have to worry about that. It's called a degree of freedom. So you have 9 data point, freely determined 4, and the other 1 is based on that 9. But you don't need to know that. You don't ever have to know that for this class. Just remember the formula for the sample variance. You gotta subtract it from 1 in the denominator. So right here, population sample. The difference is instead of divided by the whole size, you take 1 out if you do the samples. In statistic, if you see Greek letter, that means they talk about population. If you see Roman letter, that means they talk about sample. Okay. Yeah, sure. I'll post it on. I'll post it on as well. So recap, what is the standard deviation? Yeah, how far each data point from the mean, right? On average. Go back to our usual slides. Right there, standard deviation S. Here I use S, I mean sample standard deviation. Is a measure of the spread of the observation. Observation is the same thing as data point. It's a different word for it. Data points from the mean. If you have a population where or sample where all the value of each of the data point are kind of close to each other, then your standard deviation is smaller compared to the population that or sample size that have a lot of variation in each data point. Here is a compact. You see that on the slide earlier, variance. Right out here. If I would expand that out, it looks like that. Here is summation. In Greek, it's a capital. But it's summation, sample summation in mathematics. Has anyone ever traveled to Greek? And anyone here is from Greek? No? I thought it's cool. If I go travel to Greek, it'll be, I see math everywhere. Their language, right? We use a lot in math. The delta, the epsilon, all that. It was very cool. Seeing the Greek size, all math notation. If I want a standard deviation, sample standard deviation, what do I do? How do I get S from S squared? Square root, right? Deviation. All I do is take the square root. Don't worry about the plus minus, it's not like in math, just square root. The French fry data. Oh, good. I want you to go to your Google Sheet. If you forget, click here. That's mid side. It should save in your Google Drive, right? If it doesn't save, then it's somewhere up here. Right. Oh no, that's income data. Right here. Click here for French fry data. It's all the way up top. If I would have calculated by hand, say my first French fry data set. Let me see what is my French fry data set. First one. 78. I know 78, 72, 69, etc. If I would have used a formula, I'm gonna take 78, subtract. What is the mean? The mean is 69.75. So I know that from the data set, I know the sample mean is 69.75 grams. So 78 subtract 69.75, and then what do? You spread it, and then you add another data point. Another data point is, I forgot already, was it something? 72, 69. and then 72 subtract 9.75, and then you square it, and then you keep going. I don't know about you, but I don't feel like doing it by hand. Keep going till the last data point. Divided by n minus 1. N minus 1. How many data points we have here? 14. I'm sorry, we have 16. Subtract 1, which is 15. Then you plug in your calculator, you have that. I'll wait for you to finish writing that, and we're going to use Google Sheet to calculate it. Oh no, I forgot to. Oh, I'm recording. Sorry, I thought I forgot to record. All right, let's use the computer. Let's do s squared. Let's do s first. Let's do s first. So equal std ev. But as soon as you type in st, and then it'll come out for you, so standard deviation, and then you highlight that data point. I mean, data that range right there. 18.5. What does 18.5 mean? The spread of the data set, the data set. So that means, on average, the weight of the French fry is 18.5 or 18.6 grams away from the mean. How do I calculate variance? There are two ways you can do this. Either you can square that, or I think there's a command as well, bar variance. $345.8 grams, which is kind of difficult for us to interpret. Excuse me. Excuse me. In R, you could just use SD, and then inside you put your data frame. Right. What was the value? 18 point. Huh? Thank you, gram. Don't forget the unit. I'm not going to show you here in R. You can try it at home. Excuse me, I'm sorry. It's everything I teach in with the chocolate. I cough these and right now, once I have the standard deviation value, what do I do to it? Well, you're gonna tell me what that means, or you're gonna tell your boss what does that mean. So here is the generic. I'm gonna use the French fry data to show you the generic way to of interpretation of standard deviation. On average, you always start out with on average. Either start out with it or end with it. I usually start out with it. comma. And then next, we're gonna put in your contacts. In this case, the weight of the small orders of French fries. Context is important. Right? You tell the reader what are you talking about. And then go back to the generic. Roughly, you can use the word roughly. Or you can use approximately. Or you can say about. Doesn't matter. Something not too strong. Like I said, statistic, we don't like strong words. And then here will be the standard deviation value. On average, the weight of the small order of French fry are roughly 18. I'll use black. 18.6 gram away from the mean. So right there, that's your standard deviation value. Away, I'm gonna say away from the mean way. Go back to red again. I don't have space to write that, so I'm just gonna put line. The way away from the mean way. What the mean way is? Forgot what value was it? 69.75. I'm gonna put X bar. Wait, I don't have enough space, so I'm gonna say X bar. The value of the sample mean. On the exam, you will be asked to attribute the standard deviation. That is the generic way of doing it. So you always start out with on average, and then contacts, right? And then you say approximately or roughly or about, and then the standard deviation value away from the mean weight, mean height, mean age, whatever, right? Of the sample mean values. Okay. What does S equals 0 mean? If standard deviation is 0, S is standard deviation. If the standard deviation is 0, mean what? Yeah, that means that the numerator is 0, right? That means each data point is the same value as the mean. You take data point minus the mean. So there's no variation. Everybody is the same. What kind of distribution remind you of? What distribution is the same everywhere? Huh? Yeah, uniform, right? So no variation. Like the mean standard deviation S is a measure, is one of the measures, right? In this case, measure of spread, is a measure of a normal curve. Is a measure of a normal curve. Remember the normal curve, that bell curve shape? We use the mean and standard deviation for measuring. The mean is for center, right? Measuring center. And the spread the data respectively when do I use file number summaries? Remember the box plot thing? Min, max, Q1, Q2, Q3. The file number summary is better for a quick overview of the data values and information about the center and the breadth spread. Because if you look at the file number summary, what do you see? You see mean, you see median, right? So that means, well, you see median. Median is one of the measures of the center. What else you see in the file number summary? Q1 and Q3. What can you get from Q1 and Q3? IQR, that's a measure of a spread. Right? It's kind of like standard deviation here. So looking at that, you'll be able to kind of have a picture of what is the center, what is the spread. I'm gonna highlight this one. This is important. So it'll be on your exam. We almost there. Yes. The remember last time we did about box plot? Right here, that's your file number summary. Yeah. There's 5 of them, right? 5 values. Yes.
I want to make sure the center is just like the highest peak in the bar graph or histogram.
Oh no, the highest peak on the histogram.
They also release like the median.
If it bell curve, then the mean and the median are roughly the same.
Okay.
Almost there. Well, 2 more slides and we'll do the quiz. We're going to calculate the standard deviation by hand. For me, I'm not very keen to doing this, but I just gotta show you because when you go to different class, they do that. So I gotta show you. When I took this class at OU, I had my undergrad degree at OU. I had 2226. You had that one? Yeah. We do it by hand. It was like 10 years ago or something. No, 8 years ago. Yeah, it was by hand. So I gotta show you how, in case you take another class, they make you do it by hand. All right. Radon is a naturally occurring gas and is the leading cause of lung cancer in the US. I don't know why the number 12 there. I mean nothing. It comes from a natural breakdown of uranium in the soil, enter the building through cracks and other holes in foundations. Radon is found throughout the US, but the level varies considerably from state to state. Blah, 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 blah. Protection Agency recommend using one of the methods, if the measure level in a home is above 4 picocuries. I have no idea what that is per liters, but that's okay. This is just the unit, right? It's just like mercury per gram, something like that. It's just unit. We don't have to worry about that. For reading from Franklin County, Ohio, where the county average is 8.2 ppl. I'm gonna call the picocuries per liter ppl. Whereas 3.8, 1.9, 12.1, and 14.4. So those are your data points. First step, you need the mean, right? So X bar, add them all up. Divided by 4. That's what I got too. 8.05. Don't forget your unit, ppl. Oh, 8.05. Sorry, yeah, 8.05. My bad. Now we're going to calculate the standard deviation. Let me remind you the formula. S equal, I don't have enough space to realize that. I'll write that. I'll try to write small. S equal square root of x1 minus x bar square plus x. You don't have to write this step down. F2 minus x bar square plus 3 minus x bar square plus x4 minus x bar square divided by n minus 1. 11. X1 is 3.8 minus the mean is 8.05 square plus 0.9 minus 8.05 square plus 12.1 minus 8.05 square and last 14.4 minus 8.05 square divided by 4 minus 1. Let me tell you the happy ending. You can put in your calculator, but I'll tell you the result. 6.1267. Yeah. Can someone tell me, can someone interpret that for me? Put it in context. You start out with on average, comma, right? On average, and then now the context. The level, right? Let me highlight. Oops, sorry, too dark. The level measure in what is the radon? Right here. All right. The measure, right? The measure level in radon. So that's your context. On average, the measure of level in radon approximately or about or roughly, and then what next? Standard deviation value roughly 6.1267 ppl away from the mean. Yeah, from the mean, the mean measure level of 8.05 ppl. It takes time. It takes time. Let me show you how to do this in calculator. If you don't like Google Sheet or R. I have your graphing calculator with you. You can follow the step here. First, you're going to press stat. Hopefully, I have that. Yes, I do. See if I can. This. Let's see. Yeah, I put document. You know, I really rarely use this. Yeah. What a lot of professors use. Never mind. Stat. And then edit. You see edit. press edit, and then you see L1, L2, L3. Plug in the value. So stat, edit. Everybody okay with that stat? And then plug in 3.8, enter 1.9, 12.1, 14.4. Number 2. Everybody plug in. Step number 2 is a press stat, then scroll over the count. So stat again, press stat, and then on the right side, on the second line, press cal. Then 1 var stat, 1 variance. The 2 here is mean by variance. Press enter. I got 5 number summary. I got X bar, which is 8.05. Sorry, I couldn't show you. I got SX, that means your sample standard deviation, 6.1, and then your sigma X is population standard deviation. And if you scroll down more, you see 5 number summary, right? The standard deviation is 6.1267. Yeah, that's what we got. Everybody good? Oh no, that's wide cut, clear. Don't go out of it. Quit, second quit. Second quit. You go to stat, and then edit, enter. Then plug in data point. 3.8, no, 3.8, we go on, we just did 3.8, 1.9, 12.1, 14.1. Now go to stat again, go over calc, go over, just press enter. And there you go. That's right here, that's for value. Okay. It's good for small data set, but I was never a fan of this statistical calculator. Especially nowadays, we have big data. If I have 100 values data point, I don't think I'm going to be very nervous entering those points on the calculator. Yay, we done. All right. Do you have any? Yes. Not in this group. Do you have any question before the quiz starts? Once you're done, you can leave. What I want you to do, I want you to turn yourself around so that I can see your laptop. The people in the back, you want to go to the front. So your turn. More chair here.